Hi all, how we doing? I just wanted to start this set of slides, and I'm not going to comment on every slide. I don't feel the need to here. It's not as incredibly technical. I'm just going to focus on the things that are tricky to understand and confusing. So I wanted to start with this just as a kind of an introduction. By now in class, I probably did a kind of a family tree of somebody, and we separated the question of how things happen, life comes about, life changes, how things happen, as opposed to who or what might be responsible. And I frame that as a question that unfortunately um, some find hard to separate those as two separate questions. But I thought I'd show you a couple of little quotes here. Here's one that Darwin ended his book with, his great book on the origin of species, um, that introduced an evolutionary outlook to the world, basically. Darwin was often seen as being anti religious because he basically claimed that instead of a supernatural creation, which I'll expound on the next slide in just a second. Darwin said, we have figured out how that can be done, and it doesn't need a puff of smoke, supernatural, bam, create whatever kind of living things. I think we can start to figure out how that can happen using this process we call science, but it doesn't take a creator out of the picture at all. In fact, this is what this statement by Darwin was saying. His revelations, Darwin's, made him more religious than he was at the beginning. And I'll go to the next slide and look at Louis Pasteur saying the same thing. A little bit of science distances you from God if you don't understand that science is just trying to answer the how question and not the who or what question. It might seem like, since you figured out that human beings, for instance, came about in a different way than puff of smoke in the Garden of Eden, if you figure that out, that might at the surface seem to distance you from God. But if you really understand it, it produces in your mind a creator that is astonishing, brings you nearer to him. Now, all this stuff is quite personal to all people, but I just wanted to start. I always like to start with that um, statement that understanding how living things got here, that for instance, cats and dogs and pine trees and you, that they could have all been created in a puff of smoke, just like they are, but the evidence now is overwhelming that all those things came from a single beginning, and it's the similarities in all those things that have suggested that to us. And we've talked about a whole bunch of those already, mainly DNA sequence similarities. That suggests that, you know what, this is an astonishing creator. Starting with one kind of living thing, this creator created all these different living things, and we have figured out a good bit of the process of how that creator did that. And that's what brings you nearer to the creator in Louis Pasteur's mind. He was pretty smart, by the way. So, just one more famous person here, Martin Luther King, kind of said the same thing this way. Science and religion are complementary. They are not rivals at all. They do good things for each other, so to speak. If your whole view of medicine, and I'll just use medicine as an example, if your whole view of medicine is based on irrational, superstitious, um, supernatural, we need to drive the evil spirits out of this person, as opposed to figure out what is actually causing this disease or whatever, and try a way that we can test and figure out how to fix, then you're in that that valley of crippling irrationality, in Martin Luther King's words. And what religion does is keep science from becoming too, I don't know if materialistic's the right word. It's probably, well, he uses it here, but just life having no meaning. Um, Without a little dash of religion, um, then it, life could evolve into that, so to speak. See what I just did there? Hi, so I'll just make some short comments about each one of these categories of evidence for evolution, just so we're clear. Why is this evidence for evolution? So we start with the one that was the first evidence for evolution, and that was the discovery of all these kinds of creatures that aren't around anymore. That in itself is change, right? So that's one thing. Their mere existence tells us that different living things used to have been on the earth in the past. And then the fact that there's similarities between those living things and modern things, and that as we find more fossils, we can put together a very clear picture of what kind of changes most likely occurred when ancient 100 million year old species A looks like it might have evolved into species B because of similarities, and then C and D, right? This is not a special creation kind of story that D was created, specially just like we find them today. So this story, the fact that these exist, suggesting a change over time, is what evolution is, right? From this kind of organism to this kind of organism, its descendants, right? And that they're different as time goes by, just like you're different than your great 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 grandfather in a smaller sense. Their very existence is then evidence for an evolutionary process as opposed to a special kind of creation process. So here's a quick note on category two. Similarities suggest relatedness, right? Just like when we look at two people, right? Person one and person two, and they look a lot alike, the first thing that comes into our mind is that they're maybe brother and sister or from the same family. Why do we think that? Because we know how this works now, heredity. We know where you get your traits from. You get them from your ancestors, right? And so if several different kinds of things have similarities, that suggests they all got them from the same place, that they share a common ancestor. Even if they're different now, like you and your brothers and sisters, or in a much, much longer sense, if we go way back in time to that common ancestor, we have come to understand the mechanisms, which we'll talk about soon, as to how puppy dogs and pine trees and cats and you can all come from the same place. Your similarities suggest that. They suggest it very strongly. It is once again the best explanation for those similarities, and therefore it's evidence for that best explanation. The existence of these similarities is the evidence for it. So we see the molecular level, the all the way up to the body part level, right? If you're an IB, that pentadactyl limb, penta 5, right? Dactyl fingers, the pentadactyl limb that is so different in a bird and you and a whale. That is by name one of the homologous structures. But the strongest evidence of similarity, especially because it's quantifiable, is how similar is the base sequence of your DNA to all these cats and puppy dogs and pine trees. I don't even think this is even in the list of categories of evolution anymore in AP or IB, but it was one of the first things that was noted when people started to travel around the world and naturalists started to find fossils and things. So here, this category overlaps with fossil category. And the question, why do we find fossils of this kind of thing here in South America and here in Africa in rocks of the same age, but nowhere else? The best explanation is that these land masses used to be together. This kind of creature spanned all of them. And then when the continents split apart, those kind of creatures might have evolved into different things in different places in the world. And this is all backed up by the fossil record. So this, again, the best explanation is an evolutionary one, right? As opposed to, well, a creator specially created these things here in South America, and then of all the places in the world, happened to choose this part of Africa to put those same kind of creatures. It's just a better explanation, this one, that has to do with continental drift and an evolutionary process. So that final category may well be the one that you would say is the strongest. It's like the smoking gun evidence. Okay, if this evolutionary process happens, can you show me it happening today? And we have literally hundreds, probably thousands of documented examples of evolution happening right before our eyes. And the best place to look is fast reproducers. So usually little things like bacteria cells, bugs, insects, things like that. So we have some specific examples in here, right? The rock pocket mice, that gene was specifically named. We looked at that. Ice fish used to be in the AP syllabus. It's a neat example, so I keep it in here, but it's not a specific need to know. But the big one overall, by far, is antibiotic resistance in bacteria. This is the biggest example because it's also the most impactful to human health and to the health of everything. The fact that we have seen and continue to see bacteria cells evolve resistance to these chemicals which would otherwise kill them. We are seeing the evolutionary process in action in real time, and there can't be any stronger evidence. These kind of resistant bacteria cells didn't exist before, they do exist now, and therefore this change over time is as clear as it can be in those and many other creatures that we've used examples of. And there's a whole bunch of other examples that, we don't have time in a lifetime to look at. Just a quick note here, because this is right from the AP syllabus, and one of those things where the boss lady makes comments about common mistakes, and that is being careful to avoid writing statements that are Lamarckian. All right, Lamarckian kind of thinking is almost by definition that you can't acquire traits during your lifetime, like learning how to play the piano, and pass that trait on to your child. Now we know epigenetically that kind of thing. We're changing our views about that a little bit, but not in a real genetic way. And that was a Lamarckian kind of mistake, at least possibly. But really, what the statements that are Lamarckian are more about, and we're going to really focus on this coming up, is saying things like evolution occurred so that something could happen, so that some advantage can be gained. Giraffes evolved longer necks so that they could reach the leaves on the top of the trees. That is probably not something Lamarck would ever say, but it is given his name as Lamarckian, and so that's what we're really going to focus on, the language that we use to describe how this process works.